Have you ever been scrolling through an app and it just feels like it can read your mind? It's kind of spooky, right? Well, today we're going to pull back the curtain on the secret architecture that powers all of it, from your Netflix queue to your YouTube feed. It all kicks off with a really simple question. How does a platform like Netflix or any of these huge services know exactly what you want to watch next? Is it some kind of magic, or is it one of the most sophisticated, mind-bending pieces of engineering on the planet? The heart of the challenge is this number. We are talking about millions upon millions of items, movies, songs, products, you name it. And for every single person, every single time they open the app, the system has to dig through this gigantic ocean of content to find that one perfect suggestion. And that, right there, is what engineers call the million-item problem. See, it's not just about finding a good recommendation. It's about finding it in the blink of an eye for millions of people all at once. It is a massive, high-stakes puzzle. And here's what makes this so ridiculously hard. The system has to be crazy fast. We're talking under 100 milliseconds. That's literally faster than you can blink. It has to work at a massive scale for millions of people and items at the same time. And on top of all that, it has to be deeply personal for you, but also constantly up to date with brand new stuff. I mean, how is that even possible? Well, the secret is a really elegant piece of design. Instead of trying to solve this impossible problem all in one go, engineers break it down. They use a two-stage solution, and this, right here, is the key concept that makes the whole thing work. This is it, the two-stage recommendation system. Its whole job is to take that giant pool of millions of things and, in a really smart and efficient way, filter it down to just a handful of perfect suggestions that are picked just for you. Think of it like a funnel, right? It's a brilliant way to picture it. First, in step one, candidate generation, the system casts this wide but intelligent net. It goes from millions of items down to maybe a few hundred that seem promising. Then, in step two, ranking, it gets super meticulous. It scores and sorts those hundreds of items to find the absolute best ones to put right at the top for you. So let's zoom in on that first stage, finding those candidates. The name of the game here is speed and just getting in the right ballpark. It's kind of like telling a librarian you like sci-fi, and they just grab a whole armful of books from that shelf for you to look at. They're not picking the one perfect book yet, just getting the possibilities. Now, there are a couple of main ways they do this. The classic way is called collaborative filtering. It's a simple idea. People who liked this movie also liked that movie. It works pretty well, but it kind of struggles if you're a new user. The more modern approach, what the big players like Netflix and YouTube use, is embedding-based retrieval. This is way more sophisticated. It uses something called a two-tower model to basically create a giant map, a similarity space, where you and every single item have a location. It then just finds the items that are closest to you on the map. It's way better at handling brand new content, which is a huge deal. Okay, so we've cast our wide net, we've got our few hundred candidates. Now comes the really cool part, stage two, the final ranking. This is where the system gets out its fine-tooth comb and gets incredibly precise to find the absolute perfect match for you right at this very moment. At this stage, it is all about one word, precision. The first stage was all about speed and being broad. This stage is about using a ton more data to make a really, really accurate prediction about what you are most likely to click on or watch or buy. And how does it get so precise? Well, it looks at a huge number of signals or features. It's looking at user features, things about you, like your age or location. It's looking at item features, like a movie's genre or how popular it is. And this is really cool. It looks at context. It knows if it's a Saturday night and you're on your TV, so maybe you want a long movie, but if it's Monday morning and you're on your phone, it's going to recommend a short video clip instead. So smart. Okay, now here's a little nugget of insider info, something you'd hear in a high-level engineering meeting. When picking a model for this ranking stage, there's a big trade-off. Engineers often use something called GBD, or gradient-boosted decision trees. You can think of them as a really smart series of if-then questions. They're super reliable and stable. But when you have just an insane amount of data, they often move to DNNs, or deep neural networks. These are more complex, brain-inspired models, but they can uncover really subtle patterns that the other models might miss. But, building the model is really only half the story. To get this thing working out there in the real world, you need this whole support system around it to handle all the testing, the training, and the tough trade-offs that come up every day. And a super critical piece of that support system is the feature store. The best way to think about it is like the system's perfect, reliable memory.
It makes sure that the data the model was trained on offline is the exact same data it uses for live predictions. This one thing prevents a whole bunch of really subtle, hard to find errors.
So, what about that classic puzzle, the cold start problem? What happens if you're a brand new user and the system knows nothing about you? Well, it starts by showing you what's generally popular. And for a brand new item, like a new movie that nobody's seen yet, it cleverly looks at its description and genre to find similar items and recommend it to people who liked those. And this is so important. You can build a model that looks absolutely amazing in the lab. The offline test scores can be through the roof. But the real test, the only thing that actually matters, is what happens when real people use it. That's why A/B testing is the final authority. Does the new model actually make the experience better for you? That's the only question. You know what? This one sentence right here, this is the whole thing. This is the expert's blueprint all wrapped up. It's that scalable two-stage system, using modern candidate generation and precise ranking, and it's all held together by those crucial support systems like feature stores, training pipelines, and of course, constant A/B testing. That's it. That's the machine. So the next time you're scrolling your feed and that absolutely perfect recommendation pops up, the one that feels like it was made just for you, you'll know what's happening behind the scenes. So the question is, what are you going to see? Are you going to see the magic? Or are you going to see the beautiful, complex, and incredibly intelligent machine at work?